Hello, welcome to Recitation 4. Today's learning objectives will be to interpret data visualizations and quantitative comparisons, estimate descriptive statistics from visualizations, and use histograms to identify the shape of a data distribution, for example, if it's symmetric, right skewed, or left skewed. So task 1. The histogram shows the sizes in acres of 169 farms in Lake County. Approximately what percentage of farms had sizes between 0 and 150 acres? So spoiler alert, it's approximately 85%, but let's talk about why around 85% of the farms have sizes between 0 and 150. So here, how I first go about solving this issue is, so this vertical, our y-axis, is the number of farms, and our x-axis, the horizontal axis, is the size of the farm in acres, of the farms in acres. So here I go and look at approximately, okay, how many of I look at the y-axis and determine the number of farms for each of the bins in the histogram. So here, this first bin from 0 to 50 acres, there's around 61 farms that are that size. And then from 50 to 100 acres, there's approximately 55 of farms that are that size. And then from 100 to 150 acres, there's around 25 farms uh, that are that size. So the question asked again, what percentage of farms had sizes between 0 and 150 acres? So if we add up the height of these bins, we'll get the number of farms that are 0 to 150 acres. But in order to get that proportion, we also have to know the total number of farms that we're dealing with. So we also have to see how tall the rest of these bins are. And then what we'll do is we'll add up all of the heights of the bins together, and that will give us the total number of farms. So if we continue, we already have 61, 55, and 25, but then if we continue, so we have around 10 farms that are between 150 and 200 acres. We have around 5 farms that are 200 to 250 acres, another 5 farms that are 250 to 300 acres. And then we have around 5 farms that are this large size of 400 to 450 acres. So if we add up that, we get a total of 166 farms approximately. So we would just take 141, which is the number of farms that were in that size we were looking for of 0 to 150, and then divide that by the total, and we get around 0.8493, which is approximately 85%. Task 2. The following the XLStat histogram summarizes the data for the 144 firms who experienced some monetary loss due to malicious insider actions. All right, so which measurement class contains the highest proportion of respondents? So here, if we look at the histogram, if I were to select which bin has the highest proportion, this I kind of colored in the bin that jumps out to me. So the answer to A would be this bin, which is 10 to 20. Part B is, what is the approximate proportion of the 144 organizations that reported a percentage monetary loss from malicious insider actions less than 20%? So here we have around 20% monetary loss. So we are interested in what the relative frequency is of the first 2 bins, because the first bin is 0 to 10% monetary loss and the second bin is 10 to 20%. So the first bin is around 0.3 is the height, and the height of this second bin is around 0.38. So if we add 0.3 and 0.38, we get 0.68. And so that is the approximate proportion of the 144 organizations that reported a percentage monetary loss from malicious insider actions less than 20%. Okay, part C. What is the approximate proportion of the 144 organizations that reported a percentage monetary loss from malicious insider actions greater than 60%? All right, so here, if we were to look at the monetary loss in percent, we have, let's start with 60%, and we're interested in the greater than 60%. So here I kind of am just guessing that the height of this is 0.06, the bin that's from 60 to 70. Then this bin that's from 70 to 80, the relative frequency is approximately, if I were to, look at the y-axis, it's close to 0.025. Here from 80 to 90%, if I were to follow that line, oops, sorry, it's hard with the mouse. That's approximately 0.03. And then from the 90 to 100%, we have the height of that last bin around 0.04. So if you add those together, I got around 0.155, but this is just an approximate or an estimate. The professor got 0.14, but it's in that ballpark. About how many of the 144 organizations reported a percentage monetary loss from malicious insider actions between 20% and 30%. So if I look between 20% and 30%, so I know we're going to be talking about this bin, and we want to know how many of these organizations reported a percentage monetary loss from malicious insider actions between 20 to 30%. So here we would take the relative frequency, which I estimated is around 0.11. And so I would multiply that by the total number of firms, which is 144. And when you do that multiplication, I got around 15.84. And that's just an approximation. When the professor did it, he estimated that that height was 0.1. So you would do the same thing, 0.1 times 144, and he got 14.4. So these are just estimations. And sometimes using a straight edge or a ruler can help with this, or using like your pencil, for example, if it's an exam and you're trying to see, especially for the further bins, what those height of those bins are. Okay, task 3. Consider the horizontal box plot shown below. So now we want to find the median, the upper lower quartiles, the interquartile range, whether it's skewed, and we'll come back for these. So what I first did was I started labeling the parts of the box plot. So here we have, this is the lower quartile, this line here is the quartile 2 or median, and then here is the upper quartile. And so the first question asked us, what is the median of the data set approximately? So the median here would be approximately 4. And then the second question was, what are the upper and lower quartiles of the data set approximately? So the upper quartile is approximately 6. This line lines up with 6 approximately. And then what the lower quartile is what this line lines up with, which is close to 3. So that's the lower quartile. And then we want to know what the interquartile range is. So that's the upper quartile minus the lower quartile. So that would be 6 minus 3. So this range is around 3. Is the data set skewed to the left, skewed to the right, or symmetric? So here, if we were to look at um, first, okay, the this from 0, I guess, to the first quartile is 25% of the data is contained in that interval. And then we have another 25% of the data contained between the lower quartile and the median. We have another 25% of the data between the median and the upper quartile. And then we have our remaining 25% between the upper quartile and oh, this line should be extended all the way to the outliers, both these lines. I missed that outlier when I was drawing these lines. But that's another 25%. So here, it's clear that it's not symmetric. But now let's talk about, and why it's not symmetric is because if we were to look at how much, if we were to look at each 25% chunk, they're not all the same length. So we know that it doesn't look symmetric. So from the median, we don't have this nice, we don't have the size of the boxes the same length, or do we have these whiskers the same length as well? So we know that it's not symmetric, but now is it left skewed or right skewed? So here we have the spread of the data to the right, so it's right skewed. Another way to think about that is we have 25%, so most of the data, let's say if we're looking at like 50% or 75% of the data is all between 0 and 6. And then we have a the remaining 25% from 6 all the way to 16. And so we can see that there's less data kind of like, well, not, yeah, like spread out to the right, so it's skewed to the right. The next question asks, sorry about that, what percentage of the measurements to the data set lie to the right of the median and to the left of the upper quartile? So first, let's look to the right of the median. Sorry. Okay, so to the right of the median, here's the median. So we have 50% of the data that lies to the right of the median, or you can look at, okay, we have 25% in between the median and the upper quartile, and then another 25% from the upper quartile to the last outlier. And like I said, this 25% should go all the way to 16, and this 50% should also go all the way to 16. So here, 50%, so you can either think 25 plus 25, or we have 50% of the data that lies above the median. And then the other question was, what percentage of the measurements in the data set lie to the left of the upper quartile? So here's the upper quartile, and we want to know how much of the data set lies to the left of it. So here we have 3 25% chunks, or equivalently, we have 75% of the data that lies to the left of the upper quartile. The last question is to identify any outliers in the data. So here are the 3 outliers. So we have an outlier that's 12. This is in between 12 and 14. So I'm guessing that it's 13. And then this is 16. So the outliers are 12, 13, and 16. All right, task 4. Consider the horizontal box plot shown below. So the first question is, what is the approximate median of the data set? So here, I like labeling again what the first quartile, the median, and the third quartile is. So the median here is approximately 16%. The median is also Q2, quartile 2. Okay, the second question is, what are the approximate upper and lower quartiles of the data set? So the upper quartile is approximately 17, that's Q3, and then the lower quartile is approximately 13. C is we want to know what is the approximate interquartile range of the data set. So the interquartile range is here, and we can find that by doing Q3 minus Q1. So that would be 17 minus 13, which that answer is 4. Part D, is the data set skewed to the left, skewed to the right, or symmetric? So here we can see that it's not symmetric, and that the spread of the data is to the left, so it's skewed to the left. What percentage of the measurements in the set lie to the right of the median and to the left of the upper quartile? So first let's look at the percentage to the right of the median. This is the same as the previous task. So to the right of the median, we have 50% of the data that lies to the right of the median. And then the second part was what percentage lies to the left of the upper quartile. So here's the upper quartile. So you can think of it as we have 3 25% chunks, which is equivalent to 75% of the data. Identify any outliers in the data. So here we have 2 outliers. Oh, and so we have 3 and 4 are our outliers. And I apologize, this 25% here that I drew, actually, this line should be extended to the furthest outlier. I made the same mistake in my drawing. But just to be clear, from the first data point, the minimum, which is approximately 3, to the lower quartile, which is approximately 13, that contains 25% of the data. Okay. Task 5. A sporting goods store sells 3 different brands of golf clubs: Nike, Callaway, and TaylorMade. For the last 100 sales of golf clubs, employees recorded both the brand purchased and the age of the customer. The side-by-side box plot shows the age distribution for each brand. Use the plot to make decisions in the quantitative comparison below. In each case, select the most appropriate statement from the following choices. You may use each choice more than once, so we'll have to decide whether quantity A is greater, quantity B is greater, the quantities are the same, or if the relationship cannot be determined without more information. So here are what the box plots look like. And so here are the different quantities we're comparing. So we want to see which quantity is larger, or if they are equivalent, or if the relationship cannot be determined. So first, we are comparing the interquartile range for Callaway and for Nike. So the interquartile range, again, is quartile 3, or the upper quartile, minus the lower quartile. So the 2 teams, again, that we're interested in are Callaway and Nike. So first, let's look at the interquartile range for Callaway. So Callaway is this far left box plot. So if I were to guess or estimate, the lower quartile is approximately 37, and the upper quartile is around 45. So the interquartile range is equivalent to 45 minus 37, which equals 8. And for Nike, the lower quartile looks to be approximately 32, and the upper quartile is 45. So the interquartile range you can find by doing 45 minus 32, which is 13. So here, the interquartile range for Nike is larger. Another way to kind of just look at it without necessarily calculating all the numbers is if I were to look at which range is larger between these first two. And this is convenient because the upper quartile is equivalent. They line up uh, pretty nicely. I can see that just by looking at Callaway versus Nike, Nike has a larger interquartile range if I look at the distance between this hinge and this lower hinge, versus this hinge and this lower hinge. So just by eyeballing it, I can see that Nike has a larger interquartile range. So the answer is B because here is what we can select. So B, quantity B is bigger. Okay. Now we're going to compare the maximum value for Callaway and the maximum value for TaylorMade. So here, the maximum value for Callaway is around 58, and the maximum value for TaylorMade, there's no outliers, so the maximum value is approximately 55. So the maximum value for Callaway is larger. So that's A. And A is, just to refresh your mind, is that the quantity A is greater. Okay. Now we're comparing the mean for Nike versus the median for Nike. So Nike is this center box plot. So here, this thick black line is the median, which is Q2. That is approximately equal to 36. And now we want to compare this value to the mean. So we can't really, we can kind of guess what the mean is, but a way to answer this question without necessarily calculating a number for the mean is to look to see, is this symmetric or skewed? So if the box plot is approximately symmetric, which in this case it's not, but if it were symmetric, then we would have that the median is approximately equal to the mean. But here, this box plot is skewed, and it's skewed to the right. Because for these larger values, we have a larger spread versus to the left, we don't have as much of a spread. So it's skewed to the right. And when we have a histogram or a box plot that's skewed to the right, our mean is going to be greater than the median. And that's because the mean gets affected by these larger values out here. The mean is greater than the median. Next, the proportion of Callaway customers older than 40 versus the proportion of Nike customers older than 40. So here, if I were to look, 40, let's go to where I drew. So 40 is approximately this orange line that I'm drawing through both the box plots. So here for Callaway, this actually lines up quite nicely with the median. So 50% of the data is above this line. And for Nike, the median is actually below this line. So less than 50% of the data is above this line. So that would mean that quantity A is larger, which is the proportion of Callaway customers is older than 40. So here it's around 50%, and then this value is less than 50%. Okay, and then lastly is to compare the 75th percentile for TaylorMade and the 25th percentile for Callaway. So the 25th percentile for Callaway is 37, and the 75th percentile for TaylorMade is 41. So if we were to compare 41 to 37, 41 is larger. So that means the upper quartile for tailor-made is larger than the lower quartile for Callaway. So that would mean quantity A is larger. Okay, next, the intern who was preparing the report forgot to label the age histograms they made for each brand. Use the box plot to determine which brand's age distribution is displayed in the histogram. So here we have a histogram, and essentially we want to match this histogram to one of these box plots. So which one does it belong to? Does it belong to Callaway, Nike, or TaylorMade? So two things that I looked for when I was making this decision was I first looked at the range of the values of the histogram. So we have it range from 25 to 60. So I want to see, okay, which of these range from 25 to 60. So here we have values that are less than 25. So this I would say Callaway is not a good option. Here, Nike looks like we have our minimum values starting at 25 and goes to 60. So I would say Nike looks like a good candidate, but let's look at TaylorMade. TaylorMade has values less than 25. So, and it doesn't even make it up to the maximum value, which is 60. It stops at around 55. And if we look at the bin, 55, is one of the endings of a bin, but then we also have a bin from 55 to 60. So TaylorMade is also not a good option. So that means that this histogram matches closely with Nike. And if we look as well to the skew, we can see that this histogram is skewed to the right, where Nike, as we discussed before, is also skewed to the right. And I know TaylorMade is also skewed, but Callaway is somewhat symmetrical, or more symmetrical than Nike. So it just makes, it confirms that Nike, that this histogram matches most closely with Nike. Okay. Task 5, the standard deviation for this histogram is less than 10% more, or less than 10, more than 10, or it's impossible to determine. So a rule of thumb to kind of estimate the standard deviation is to take the range and divide it by 4. So here, the range again is the maximum minus the minimum. So the max is 60, the minimum is 25, so that's 35, and we're going to divide that by 4 to estimate the standard deviation. So 35 divided by 4 is 8.75, which is less than 10.